present today. Thank you again for joining us on the new office hours. This is going to be the last one today, October 25th. And today we have our colleagues, esteemed colleagues, Christian Ramirez and Ola. They're going to be discussing what we plan for today, some other data analytics uh, services like AWS Glue, Amazon Athena, and Amazon QuickSight. And then at the end, we're going to have a demo like we always do in our office hours. I always give it back to Clarence if you want to say something before uh, we start today.
Yep.
Clarence.
Thanks, Dineski. I'd
Yeah.
just like to welcome everyone to these AWS office hours, and thank you again for participating in the UN Datathon. I just wanted to remind you that tomorrow is our fourth UN Datathon webinar, which is a pretty important webinar. We'll be introducing the theme that you'll be working with during the Datathon, and also have an additional office hours for the pet challenge today and tomorrow. So check the website for those. And I'd like to thank our colleagues from AWS again for putting this whole series on. And those recordings are available on our website too. All right. Thank you very much. Back to you, Dineski.
Yeah. And we always send a follow-up email every time we finish our office hours with all the links and all the information that is shared during our office hours. So, Iso, is there anything you want to say?
Yeah, I would just like to say, since this is going to be our last office hour session, please just go back and watch the previous recordings, just to understand some of the services you might be interested in during the Datathon. So you'll be ready for the main event on November 3rd. I'll pass it back to Christian. The floor is yours.
Appreciate it. Thank you all for having me here today. So my name is Christian Ramirez, and I'm a partner solutions architect in the Worldwide Public Sector's Partners ISV team and a member of the Analytics CFC. So my esteemed colleagues, Dineski and Ezel, asked if I could come in to be able to provide a little bit more of an overview on data analytics on AWS. And with today's session, it's not going to be a deep dive in any way. It's going to be more of an overview of just what is really possible with analytics within AWS. And as you'll see throughout the slides, there's just so many different services that we could use within AWS in terms of analytics. So I wanted to scope this down and really just focus on a couple key services, mostly on AWS Glue for ETL and data preparation, Amazon Athena for querying data out of your S3 data lake, and then Amazon QuickSight for being able to create business intelligence dashboards. But before I get too deep into the weeds here, wanted to talk a little bit more about myself here. And I usually like to open up with just these numbers right here. Usually I would ask participants to be able to identify maybe what these numbers might mean. Some people like look at it and it's not really a phone number, it's not a social security number. It's very hard to be able to determine the value from these numbers. And these numbers here, it's like are pretty meaningless to you, but they're meaningful to me. And they're basically my life in numbers. And what 8,878 means to me is that last I checked, I rode 8,878 miles on my bicycle since I started tracking this information. So for me, I really like riding my bicycle out here in Austin, Texas. And it's just one of the things that really helps me get out and stay active and decompress after a long work day. 828 is the number of day ones that I've had since joining AWS. So within AWS or Amazon in general, we always say that we keep a day one mentality, and every day we treat it as the day one. So for those that maybe don't have a calculator on hand, this means that I've been with AWS for a little bit over 2 years. 7 is the number of AWS certifications that I have attained since joining AWS. And for me, I'm a lifelong learner and always want to continue to attain more certifications. And I am looking into the new data engineer associate certification that's coming out just at the end of this month. Four is the number of years that I worked as a teacher before actually joining AWS. So in my past life, I did work as a high school math and technology teacher, and then later transitioned into being a district analyst for a charter district based out of Los Angeles, California. And two is the number of publications that I have had with AWS. And the reason why I like to do this activity is that most numbers really don't mean anything unless we actually attach value to it. So when we start working with data within AWS, the numbers that we're working with, or the values that we're working with, really don't have any values until we actually attach it to it. So with the goal for the session today, it's like we wanted to talk a little bit more. How is it that we could work with different types of data sets and then be able to prepare them for analytics or also machine learning down the pipe? So this brings me to my next piece, which is the agenda. So for this presentation piece that we have right now, it's like we wanted to start off and just provide a little bit more of an overview on modern data architecture on AWS. And modern data architecture is not a product that we sell. It's more of a strategy and an offering that we try to provide many of our customers here. And the way that we achieve that is by being able to put together different services such as AWS Glue, Amazon Athena, and Amazon QuickSight. And that's some of the pieces that we're going to be putting together today for this modern data architecture. After we go through the slides, we're gonna have a demonstration. So for me, I have a short demonstration at the very end, and my colleague Ola also has a demonstration that he wanted to provide, and then we're going to open up the floor for Q&A at the very end. Excuse me. So, in starting our conversation on modern data architecture, why choose a modern data architecture? And when we first take a look, when we first start working with customers and we take a look at what they have, it's like we and in general, this is true of the industry. It's that we see is that currently in the industry, it's like we have a variety of data types and sources that we're working with. So no longer are we working with XML or only or JSON payloads or CSVs in this case. Depending on the industry, customers could be working from anything with geospatial data, image data, and all sorts of data that come in a variety of formats. And this makes it very difficult for many of our customers to be able to intake all that data and be able to have be able to have the tools necessary to be able to process all that data as it comes in. There's also a large need for diverse analytics, and the amount of data that we're actually starting to see now is substantially growing. And what we're seeing is that there's almost a exponential growth in the amount of data and the velocity on which it's coming through. So to be able to manage, from what we have to what we need, is that first we need performant services to be able to take all this data on however it may come to us. And then we need to make sure that it's something that's completely manageable, scalable, cost efficient, and provides the flexibility that we need to be able to process all this data as it comes through. And as always, we never want to compromise any kind of security in efforts for being able to achieve any kind of performance or any kind of cost efficiency. So that's not a trade-off that we make here. So when we talk about traditional data warehouses, the traditional structure could look something like this. So you basically would have, your online transactional processing, your ERP systems, your CRMs, feeding all this data to your data warehouse. And as you could almost imagine here, it's like this almost becomes like a bottleneck source here. And with the data warehouse, and this is still a strategy, of course, that many customers still implement with only a data warehouse, is that they have to do a lot of transformation of the data from the source to be able to fit it into their data warehouse. And after they get their data into their data warehouse, it becomes accessible for them to be able to generate reports and business intelligence. So this means, being able to connect your data warehouse to your business intelligence platform, whether it be QuickSight or Tableau. And this is traditionally how many organizations are able to create insight based on the data that they're getting with. So when we take a look at something like data lakes, is that we, instead of only being able to work with structured data, we could also work with semi-structured and unstructured data. So this means that in addition to working with the structured data that comes from OLTP, ERPs, or CRMs, we could additionally also work with unstructured data that could come and is constantly changing. So anything from IoT devices and their payloads, and store it within our data lake. Once it's in the data lake, we could also feed it into different downstream reporting, business intelligence, even machine learning use cases here. And the benefit of having a data lake versus only a data warehouse is that you could bring in the data exactly how it comes from the source. And then once it's in your data lake, you could then create some processes to then have the data feed into different platforms. And this is where the modern data architecture comes into place. So when we talk about a modern data architecture, this is synonymous with a AWS data lake. And at the center, you could see that we use our S3 buckets to be our data lake of choice. And this allows customers to be able to centralize and create a single source of truth of all of their data, and then send it directly into their S3 data lake. And once it's in the S3 data lake, we have different tools and integrations within AWS that will allow customers to be able to send data to out into external purpose-built databases or data stores, and also around the perimeter. So within a modern data architecture with this movement, we have what's called flow of the data going out, flow of the data going in, and also around the perimeters. So when we talk about a modern data architecture, there's a couple foundational principles. The first one is that the data lake must be scalable. So as I mentioned earlier, currently right now, the current data trends is showing that we're getting not just a lot of data, but we're getting a lot of data that is varying in different types of formats. So as I mentioned, now it's you might have different payloads that might be, they might follow more traditional XML or JSON payloads, but then you might also have some that are using Parquet, ORC, tab delimited. There's just almost no limit to the amount of different types of data types that we're working with. And even, and right there, that was only an example of something that would be more like traditional database. But we also would also start working with anything from image files, geospatial data, and even video files there. And it makes it much more difficult for our customers to be able to attain some sort of insight from this data here. The next principle is that it needs to be it needs to incorporate purpose-built services. And so traditionally what we would see is that many customers, what I like to say, it's like whenever you have a hammer, every problem looks like a nail. And what this means is that, you work with the tools that you have. And if you're working on your traditional on-prem data center, you might only have access to maybe a PostgreSQL database as your data warehouse. And so you're going to have to try to make everything fit within that, even though a relational database might not be the best best service for it. So within AWS, this is where you could use anything from a NoSQL database such as DynamoDB. You could use a variety of different relational database platforms such as Postgres, even Microsoft SQL, and some of our more cloud developed, born in the cloud database offerings such as Amazon Athena or Amazon Redshift. So the next principle would be seamless data movement. And as I mentioned earlier, there's 3 types of movement. There's inside out, outside in, and around the perimeter. And so by having a modern data architecture that revolves around an S3 bucket, it provides seamless integration between all of these different use cases. So as you'll see in the demonstration later, we're going to take some raw data and then we're going to be feeding it in. We're going to be cleansing it and preparing it for machine learning. And this is not the limits of what we could do with something like with a data lake here. And the next principle would be performant and cost effective. So by having this sort of strategy, it's like we're making sure to decouple storage from compute, and many of the services that are available there are what's called serverless. So that means that there's no underlying instance or compute instance that you have to manage. And the last piece is unified governance. So by centralizing all of your data and having it within an S3 data lake, it does provide simpler governance because all of your data is in one place. And with tools such as lake formation on AWS, it provides you the ability to be able to grant very granular permissions into the data that you have within your data lake to individual services or individual users. And that could be as granular as row level. So now that we talked about modern data architecture and some of its key principles, wanted to transition into talking about one of the first services that really makes this happen for many of our customers. And this is AWS Glue. So, excuse me. So just like the previous examples where we're talking about how the modern data landscape is just constantly changing, many of our customers are saying that that their data is constantly growing exponentially, and it's of course coming from new sources, and it's being used. So it's being written to one specific place, but then being used by so many different applications. So additionally, many of our customers are seeing the need for anything from batch and real-time processing of their data. And with using your more traditional ETL or extract, transform, and load solutions, they can't really handle the needs of these changing requirements here. Because in some cases you might have one specific, and whether it be a Python code or a SQL query, they may be difficult to scale because they might just be able to process only one specific type of data set, and doing many of these things, whether it be on-prem, could result in very high cost because you would have to manage a lot of compute resources, credentials, and everything of that sort, and makes it very difficult to be able to scale that way. So that's where AWS Glue comes in, and it provides an all-in-one data integration service for our customers to be able to do ETL operations at scale, for working with all of their different data sets. So with AWS Glue, this is how we're able to break down some of the data silos by being able to provide ETL operations. And what that would essentially look like is that we could take data from a specific source, provide any kind of transformations necessary. And when I say transformations, it could be something as simple as changing the data type from a var char to an integer, to doing aggregations on a specific column, and generate, and also doing some sort of join to other data sources there, and then loading it into your destination. And that destination with AWS Glue could be a variety of different places, including our S3, or even our Redshift data warehouse. And we'll provide a little bit more of a demonstration later on. One of the features that AWS Glue has is called the AWS Glue Data Catalog. And AWS Glue Data Catalog works with what's called the AWS Glue crawlers. And this is one of the ways that, when you get data within your data lake, it's very difficult to be able to determine the schema of something. And by using AWS Glue crawlers, what it would do is that it would take a look at the file structure and then identify what is the schema of this data that you're working with, and then publish that metadata to your data catalog. And just as the name implies with the data catalog, this makes it a lot more easier for you to be able to see, it's like, what is the data that's available within your data lake, and then have it then be queryable by business intelligence platforms such as Tableau or QuickSight, be able to load it into machine learning services such as SageMaker, and then also interact with it in real-time queries using Amazon Athena. So what this would look like in practice here is that AWS Glue could connect to a variety of different data sources. So with AWS Glue, it does natively support integration with S3, but additionally, you could also have different data sources that could be located on-prem. They could come even from different Amazon relational database service databases that you have within your AWS account, and different types of databases and formats on which it could be. So it doesn't necessarily always have to be a relational database. It could even be anything from like a NoSQL database there. And the first part would be being able to connect to the data. So with Glue connectors, that's how you can make connections to different types of data sources, and then discover the schema with our Glue crawlers. Once the Glue crawlers publishes the metadata, that's published into our catalog, and this allows customers to then be able to interact with the data and transform the data using a variety of different Glue services that we'll talk a little bit deeper in some of the later slides here. And with AWS Glue, that's what could essentially feed data into any into any purpose-built database within the AWS ecosystem. So when we prepare raw data, so when using AWS Glue, one of the additional use cases here could be for preparing raw data for machine learning. And what we constantly see is that with data that's coming in for machine learning, most of the work that we see for machine learning is actually on the data cleansing side of things. So customers traditionally would use something like Python with pandas to be able to get the data into the format that they need it to, and be able to make transformations, when hot encode the data, and then make it accessible for their machine learning services to be able to interact with it. With AWS Glue, it provides a little bit more easier interface to be able to work with this, and it could also scale up to the variety of sizes of the data. So it could be a couple gigabytes, it could be a couple terabytes, and AWS Glue would be able to scale up and be able to process that data and perform the actions that you have there. And we'll talk a little bit more about the different types of services that you could use to be able to transform this data here. So When we talk about AWS Glue, so we could kind of break it down into three distinct buckets, and they're really designed for all types of users. So anything from your business analysts that would traditionally work on an Excel spreadsheet, all the way up to your data engineer or ETL developer. And on the very left-hand side, for something that would be pretty seamless for any developer that's working on ETL would be our AWS Glue Studio. And what AWS Glue Studio provides is a visual interface for customers to be able to join different data sources, be able to provide any kind of transformations such as aggregations, or be able to remove any kind of missing fields within the data itself. And this provides a simple flow chart for being able to see, it's like, what is the path that your data is taking to reach its final destination there. The next service, which would be intended more for your business analysts, would be AWS Glue Studio Notebook. Yeah, and this one would be intended for your data engineers, excuse me. And this one would be, basically an AWS hosted Jupyter notebook where you could explore your data and be able to provide a lot more complex transformations of your data. And underneath the hood with AWS Glue, it is running Spark, and it is a distributed system here. And with AWS Glue Studio, you would be working with a specific version of Spark that is specific to Glue that allows you to work with what's called dynamic frames, but also with data frames. And the simplest version of them all would be the AWS Glue Data Brew. And I'm going to go a little bit more deeper into this one because I feel that AWS Glue Data Brew is a little bit more distinct versus your Glue Studio versus your Glue Studio Notebook. And with AWS Glue Data Brew, it provides a very simple, easy way to first profile the data and see, if there's any kind of correlations between some of the data sets, and then have a way to be able to interact with the data. So you might be working with data that might be a couple gigabytes, a couple terabytes, and something like this, an Excel spreadsheet wouldn't be able to handle something like this. And this would be a good middle ground between working with an Excel spreadsheet and then going all the way to a Glue Studio notebook. And what I mean by this is that AWS Glue Data Brew provides a much more easier way to interact with the data, be able to preview just how these changes are going to do, and then once you're happy with all the transformations, you could then publish it. So let's just take a little bit more of a deeper dive into AWS Glue Data Brew itself. So AWS Glue Data Brew is a serverless no-code data preparation platform that allows customers to really work with their data as if it was almost like in a spreadsheet, but they could get a lot more information from this. And one of the key differences here would be that when working on a project, and I'll have this within my demonstration, when working on a project within Glue Data Brew, you could make all the necessary changes, but it's not going to affect the source data. Instead, you could have different steps that it could perform, and it provides a lot more audibility and ways to be able to make any changes in the future based on the changing requirements on your data set itself. There's also some tools where you could see the data lineage. So you could see it's like, where exactly is your data coming from and where's your data going to, and capabilities for profiling the data to see, at a high level, it's like, what is the quality of your data? Like, are you seeing a lot of duplicates? Are you seeing a lot of missing values? And then be able to apply any kind of data quality rules to be able to flag any kind of data that's just not meeting that data quality standards there. So let me fast forward a little bit. So with Glue Data Brew, how does it work? So first thing that we would have to do is first be able to connect the data sources. And so with Glue Data Brew, we could work with a variety of different sources within AWS. And the first one could be like loading data from your S3 data lake. And once you load data from the variety of different data sources, you could then build what's called a recipe using the projects. And what a recipe would do, it's essentially provide a step-by-step transformation instructions without having to do any kind of code for Glue Data Brew to be able to do on your data, and then provided a destination to where to send that data once it's finished. And when it comes to destinations for Glue Data Brew, we could load data directly back into our S3 data lake, or even load it into relational databases or our data warehouse with Amazon Redshift. So now that provided a little bit more of an overview on AWS Glue, wanted to talk a little bit more about some of the use cases for AWS Glue. And the first one would be to modernize on-prem ETL tools and load data into a data warehouse. And what this could look like is that, once data reaches your S3 data lake, you could schedule an AWS Glue job to be able to be able to work with that data, but then also pull data from different relational databases to be able to do any kind of enrichment in terms of joining these these relational data sets, and then load it into your data warehouse, such as Amazon Redshift, and also feed it into your business intelligence dashboards, such as QuickSight or Tableau. And the benefit of doing this is that traditionally it's we would have these two different data sources being siloed with and by using AWS Glue, we're able to combine these two data sets that would traditionally be siloed and be able to generate insight that wouldn't be possible before. Additionally, with AWS Glue Data Brew, there's the capability for one-time processing of the data. And so if you're working with a pretty large CSV file that might have been provided to you, or this is not like a recurring data file that you're working with, you could instantly just upload it directly into your S3, and then load it into your Glue Data Brew, provide all the transformations, cleansing, and then output it back into Amazon S3. And by using Amazon Athena with Amazon S3, we could then integrate with Amazon QuickSight. And one of the last pieces here, it's that just wanted to talk about the capabilities for AWS Glue Data Brew for data pre-processing for machine learning. And as I mentioned earlier, most of the work that goes into training a machine learning model really revolves around having to clean the data, making sure that you are not feeding it bad data. And there's a common saying, garbage in, garbage out. So by using AWS Glue Data Brew, this is a feature that you could really leverage to make sure that you are able to excuse me. By using AWS Glue Data Brew, this is one of the services where you could provide all the transformations, be able to provide any kind of data quality checks, and make sure that the data that was received is cleansed and then outputted back into Amazon S3 and then used for machine learning training. One of the next pieces I just wanted to talk a little bit more about is Amazon Athena. And Amazon Athena is a serverless querying engine that allows customers to be able to query data from where it resides. So one of the common misconceptions that we have with Amazon Athena is that it's almost like provisioning some sort of like relational database. And Amazon Athena is 100% serverless, and what this means is that you don't have to provision any kind of resource and have to manage any underlying resources and security patching and all that. So with Amazon Athena, you would be able to connect directly to the data where it lives, and then be able to load it into different types of data sources, such as your QuickSight dashboard or even Tableau dashboards here. So when we talk about supported data sources, within AWS, these are the supported data sources that you could do. That you could directly connect with, but then there's also external data sources that you could connect with Amazon Athena. And this is all done possible by using what's called federated queries. And federated queries, and we're not going to be able to dive too deep into this, would be essentially in a AWS, excuse me, AWS Lambda function that would be able to connect directly to connect directly to these other sources or different AWS sources, and be able to provide that data into your Amazon Athena environment here. So let's talk a little bit more about some of the Amazon Athena use cases. And when we talk about Amazon Athena use cases, there's a variety of different use cases. And the first one, as I mentioned, it's querying data in place. So Amazon Athena doesn't store the data; it essentially just passes on the data. So whether your data lives in one of these supported data sources that I mentioned in the previous slide, or within your S3, it's not taking it out of there; it's just presenting it to you. So within our demonstration today, we'll show a little bit more about Amazon Athena and how is it that we could generate queries from it, and we could do interactive sessions with it. But then also within Amazon Athena, this is one of the ways that we would be able to connect our business intelligence platforms to be able to access that data there. One of the other use cases that I see pretty often is just for lightweight ETL workflows within Amazon Athena. And this could be anything from just creating a query that runs on a specific schedule to aggregate certain data. You could also create, just similar to relational database, you could also create a view to be able to access that data later on, and then be able to load it into your BI platforms here. So one of the first deep dive use cases that we have here would be, being able to remove those data silos. And as we mentioned, with the modern data architecture, we want to remove as many data silos that could come from it. And by using something like Amazon Athena, we could query the data from where it lives and be able to combine it in one single platform to then be able to feed it into our Amazon SageMaker for machine learning, or Amazon QuickSight for business intelligence. There's also a good use case for light ETL work, and this could be, again, working with data from a variety of different data sources and having it go through Amazon QuickSight, Amazon Athena, and then be able to drop that data directly into S3. And you can see here on the right-hand side that there's like a sample query, and you can see that at the very end, it's going to drop the data within this S3 bucket path that we specify here. And one of the last ones would be just in general for serverless data lake and analytics. So with Amazon S3, by using AWS Glue in the first place and crawling the data, being able to provide publishing the metadata within our AWS Glue data catalog, Amazon Athena directly integrates with our Glue data catalog to be able to provide interactive querying and then publish the outputs into Amazon QuickSight. which brings me to our next, into our final piece before we get into demonstrations, which is Amazon QuickSight. So Amazon QuickSight is our business intelligence platform that provides many of our customers with a low cost business intelligence platform that is delivered as a software as a service offering. And what this means is that customers don't have to buy a license for Amazon QuickSight, install it on-prem, and then have to manage any of the underlying resources. Instead, they just subscribe and pay for what they use, and they would then be able to generate business intelligence for their use case here. So with Amazon QuickSight, you could generate interactive dashboards where you could have a variety of different types of data visualizations. Customers also use Amazon QuickSight to embed their insights directly into their websites. So like that, customers don't have to, log into something like Amazon QuickSight. Instead, they would go onto their regular website and then be able to see their embedded analytics within their website itself. And with Amazon QuickSight, there's just no limit to the amount of interactive dashboards that you could create. So at the end of the session, I'll provide a link for everybody to be able to go through a demonstration environment, and they could interact with some of the data sets and see just what is possible with data analytics, with Amazon QuickSight. And Amazon QuickSight does also work pretty well with geospatial data and different types of data sources to be able to provide different types of analytics. And one of the last piece that I wanted to talk about would be the integration with what's called QuickSight Q. And QuickSight Q is a natural language querying platform that allows basically allows users to just be able to ask questions of their data, and then visualizations would be rendered to them. So this is very helpful for customers that want to be able to explore their data sets and work directly with it, but maybe don't have the ability to make new dashboards. So anything from like questions like how was our sales in Q3 2023, it would be able to provide a chart based on that query there. So next piece, I just wanted to move into our demonstration. And before we get into the demonstration, just wanted to provide a little bit of a demonstration scenario. And with the data set that I'm working with, so within the open data sets that I found, I was working with the COVID-19 data. And if there was a certain situation where we wanted to be able to use something like generative AI for text summarization, one of the things that we could do here would be to be able to provide a summary of journals using generative AI to be able to keep our people informed. So something like this could be used for, let's say if you have a large catalog of different journals, but maybe you want to be able to summarize it to maybe just 100 words or less. And be able to boil it down. This is where we could use something like generative AI to be able to provide a text summarization. And so what we wanted to do within this demonstration is first just talk about like how is it that we would approach something like this, first in terms of data cleansing, but then also generating the insight based on this data here. So without any further ado, let's get into it. Great, and let me just pull up my screen here. And while I'm doing this, is there any questions that anybody may have or anything that might have shown up in the chat that I did not see? I just need to re-authenticate over here so I don't time out. Great. So, all right. So to be able to tackle this question on like, how is it that we could be able to generate summaries on journals? So like that, individuals would be able to read a pretty condensed version of the summary and then decide whether they want to go back in and read the entire scholarly article. I'm working with this COVID-19 data lake set right here within the Open Data Registry. And luckily for me, there was a couple of documentations here on being able to generate the glue data data catalog. So if I go back here, let me just reload this. So when I ran the CloudFormation template that was provided within one of the documentations, what it did is that it created a database and a table. So right now I'm in the AWS Glue homepage. And if I click on databases, you can see here that I have one database called COVID-19 that was just created yesterday. And if I click on this COVID-19 database, then it's going to show me all the different data tables that exist here. So this right here is an example of the Glue data catalog. And there's different ways that we could populate these Glue data catalogs. And one of the ways that we could do that would be by using what's called the AWS Glue crawlers. I won't be showing a demonstration of that today, but using the Glue crawlers, it would be able to infer the schema of data that you point it to, and be able to generate the table name and the data schema itself. So if I expand a little bit more on this, and let me just shorten this right here. We could see it looks just like your traditional data, your traditional relational database here. And we could see that we have different table names, and all of these are part of this open registry COVID-19 data lake here. So if we were to click into one of these, let's see if we maybe click on county codes here. If we click into it, there's a high level information that we could see here. At the very top, we could see that this is the name of the table. It's part of the COVID-19 database. And then for classifications, this data is a CSV document. And one of the important things here that we could see is that the location is a COVID-19 is the COVID-19 dash lake S3 bucket. And one important thing to note about this is that this bucket is part of this registry here. So this is not a bucket that is registered to my account. So when creating these Glue data catalogs, we're not moving the data, we're just logging where the data resides and the metadata on that data. Because so at a high level here, we could see the schema of the data. Like we could see that, country is a string type, and then here was like a custom, some custom comments that were inputted into here. And you can see that we're also working with lat long location data here. And we could pretty much interact with the data there. So, since we want to work with, creating summaries of journal articles here. So let me see. So this is one of the data sets that has metadata on different scholarly articles. And from here, it's like you can't really identify what the data is looking like. We can see that almost everything is a string type except for one Boolean, and then just column names. This is not really giving us much information for knowing how to really work with this data. So this is where we could use something like AWS Glue Data Brew to really interact with the data and figure out what the data is telling us. So in the interest of time, I did already create these data sets, but if you click connect new data set and then just point it in the right direction, it would be able to ingest the data here and then connect the data to Glue Data Brew. So if I click on this Allen Institute metadata piece here, it's we can see that we're working with the same data sets here. So basically all of that same information is showing up here. And one of the benefits of using something like Glue Data Brew is that you could create a data profiling job, and I already created that ahead of time. But if you click on Data Profile Overview, you could see some high level statistics on that data. So we could see that it ran on 20,000 rows of data. There's a lot more data within there, but it picked a random set of 20,000 right here, just because I put the limit on there. And then we could see some of the column summaries and be able to see it's like just at a high level, like what is the data telling us, and just how spread out it is. So right here we could see that for something like so right here you could see that this one has 55% fields that are valid. So that means that 55% are actually there, but then 45% are missing. So this would be like at high level, be able to tell you whether you're working with a complete data set or really working with a lot of nulls. And this could really throw off a lot of machine learning jobs here, because you might be feeding it data that's just not there or not in the correct format that you need it to be. So yeah, and then if we go into column statistics, we could see even just more on this. But we haven't really taken a look at the actual data and just how it looks. So if we wanted to explore a little bit deeper into this, we could go into projects, and probably should have clicked on this a little bit sooner. But if when you create a project and then you initialize it here, it might take a couple minutes, and mine might take a little bit longer because it would have to make sure to validate every single step that I have here. But once it's up and running, one of the things that you could see here is that you could see all the different transformations that could be done on the data itself here. So you could see that you could filter data, you could sort data, you could do operations on the columns, and then be able to provide any kind of functions and conditional operations on the data set itself. For those that are working with things like nested fields within JSON, there's some operations here that you could use to nest or unnest data in a way that makes sense, and be able to preview that in a good amount of time. So while this is initializing and promise to get back to this page here, I'm gonna open up something else so like that it could also initialize while we're looking at this. And just going back to our AWS Glue part here, we could see that we have, if you click on ETL jobs, there's different types of jobs that you could do. There's visual ETL, which would be part of our Visual Studio. And then you also have our notebooks, which would be a lot more like just working with Jupyter notebooks. So in my case here, I'm just going to click on notebooks. And so I already have a notebook that is up and running here. So I'm just going to initialize that. Let me just check back over here. Yeah. And we could see here that, and as I mentioned earlier, this one was going to take a little bit longer because after it initializes it, first it has to go through all these steps to make sure nothing gets invalidated. So I'm just going to close this recipe slide over here. And for those that are familiar with working with something like Excel spreadsheets, this feels very familiar here, where you could take a little bit more of a deeper dive into the data. So, as we saw earlier within the profiling of the data, we were able to see at a high level, like high level statistics on the data. I didn't run any correlation matrix on it, but we could be able to explore this data as if it was downloaded in an Excel spreadsheet, but see the high level information here. So, you know, with being able to generate a summary, one of the things that I wanted to do would be first work with the abstract field here. And we could see that, so on this part right here, I did a custom operation called, where I basically wanted to see how long these are. And we could see that the length of the abstract, in this case right here, is 1,950 characters long. So we want to make sure that, you know, we're not working with these outliers like this one, that's all the way over here, but we're not working with data sets that's too small. So we want to stay within the medium. So, you know, when generating, when preparing data for machine learning, we want to make sure that we're not working with those outliers there. So I also created what's called an abstract filter, to say whether to keep the data or whether to get rid of it. And we could see here, it's like we want to make sure that we're not working with these that are only like 10 characters long, and the one that's not about 6,000 characters long. So if we go back to our recipe here, we could see that, you know, some of the operations that I'm doing here is that I'm splitting a URL into two separate pieces, using a semicolon delimiter. And yeah, next piece would be to delete the empty values within the abstract itself. Next one would be to remove any white spaces, you know, that come before or after the abstract starts. And then the next one would be to create a custom abstract length, and then generate some sort of filter on that, and then to deduplicate based on their unique ID, and then also delete any missing values there. And so based on this, when I say run job, it's going to go through and create all these actions for me. And this is just an example of using Glue Data Brew to be able to clean the data, but you could also use it to enrich the data by a very simple, easy to use join operations. So for example, now if I click on join, you can see here that it's going to take me to a new piece here. And if I had more than one data set created within AWS Glue Data Brew, it's going to create that connection here. And then we could, using a simple user interface, you could summarize how is it that you're going to be connecting these different data sources. Great. So, you know, when I ran this job here, so if I go to job details, we could see here that, so when I configured the job, it's like you just have to specify a timeout, the number of workers that you want to work on this, and what is the output going to look like. And in my case here, it's like we could see that it's going to output a new table called metadata gen AI clean. And this is what then I would use to then be able to feed into my machine learning model. So now that we cleanse the data using AWS Glue Data Brew, one of the next parts would then to be using AWS Glue to be able to transform the data into the format that we need it to be, and then also feed it into our SageMaker endpoint to be able to provide an inference in return. So if I so in this case here, it's like I already loaded up my notebook, and it feels just like any other Jupyter notebook where you could interact with it. And we can see here it's that we're using basically PySpark, but there's a Glue specific version of it that allows a little bit more features to be used within AWS Glue. And there's a difference between what's called the dynamic frame and a data frame. And a dynamic frame is something that's specific to AWS Glue. And it allows for you to be able to work with data as it's changing schemas. So I'm just going to kind of speed through some of these things. And so you can see that we're working with a pretty large data set. So I want to make sure that I limit it to just about 1,000 because I believe there's close to 200,000. And within this AWS Glue notebook settings here, similar, you could use our Python Boto 3 client to be able to hit any kind of endpoints. So for me, I've worked with customers that maybe they don't want to manage their own machine learning SageMaker instance. Instead, they want to use AWS managed services like Amazon Comprehend to be able to detect sentiment on that data. But since in our case, we want to do something that's Gen AI based in terms of like feeding it a certain summary, and then getting in return, I'm feeding it an abstract, but then in return getting a summary back. We want to host and deploy our own Gen AI instance within Amazon SageMaker. And for that, it's like I use what's called the SageMaker Jumpstart. And I am not a machine learning expert, but using Amazon SageMaker Jumpstarts made it very easy to be able to host a Hugging Face text summarization notebook within my Amazon SageMaker instance. So if we, let me just run this. So right now it's like I'm running each step one at a time, but if I was just to hit run, it would run on its own and do it in the background. But right now I like to work with more of an interactive environment. So let's say if I wanted to feed it, let me just comment this out. So if I wanted to feed it a specific example from this data frame, so I wanted to pick and I'm just picking a random instance, it would be the 9th entry within that data frame. If I hit to compute, it's going to right now return to me a summary of that. And we can see here, it's like that this is the summary that was provided based on that instance itself. Let me just close here. And sorry, if I do a print of the original text that it was supposed to do, we could see that this was the text that was provided. And just with the parameters that I gave the machine learning model, I wanted to really bring it down and just provide like a high level overview on it to really tell my so whoever's interacting with this whether they should read it or not. And so you can see here that a lot of the sentiment was kept from the summary. And of course, it just boils it down to very basic levels here. And something like this could then be fed into like a front end website to be able to provide some sort of summary on this. And this was all done using batch jobs. And before I get any further, I just wanted to provide a little bit of an overview on Glue Visual ETL. And this right here would be, so if you click So as you could note here that there's two different types of jobs that we could do a visual ETL or a notebook. If we want to do a visual ETL, it provides a simple way to do a drag and drop implementation. So if I do a, let's say if I do that my source is coming from my AWS Glue Data Catalog, and then I want to get something from the COVID-19 database, and then let's say if I pick the, let's do the metadata again. Then it's going to provide me different options in terms of transformations that I could do. So I could do anything from custom transformations, drop duplicates, filters, and a lot of these operations are similar to what we could do within a AWS Glue Data Brew. But right here, it's like you wouldn't be able to explore the data as you're doing it. Instead, it's like you're doing it more on the actual columns or data sets itself. So maybe let's just do something simple as change schema. So if you wanted to drop a table, you could do that here. If you want to change something from a string to a Boolean, you could definitely do that here. And then the last piece would be then provide a target, which would be, so in this case, we could just say S3, and then if we pick this field here, and I'm not going to run this, but you could see that what's being generated here, let me just delete that, would then result in a, so all this here, doing the Visual Studio piece of it, would actually generate what's called a script. And this is similar to what we have in our Glue notebook. So Glue Studio allows you to be able to do a no-code, low-code implementation of this here, using visual drag and drop features. And then in the back end, what it's doing is creating a script here. And the last piece of this demonstration here would be, and let me just, so with Amazon Athena, as I mentioned, we're not changing, we're not loading data anywhere. We're basically querying the data from where it lives. And with Amazon Athena, there is direct integration to Glue Data Brew, to the Glue Data Catalog. And right here, we could see that, since we only have one database, it's going to be this one specifically. And then we could see here that we have all the different data tables that we have here. So, in my case here, let's say if I wanted to explore the, let me do again that metadata one. We could see here that it's just going to do a select, everything from that one, limit 10. And then we could interact with the data here, and be able to explore it and download the data into an Excel document. And we could run queries from here. But if we wanted to do a little bit more complicated things, so let me pull up my saved query. So this right here would be a query that I ran to kind of show just how much we're able to condense the abstract in with the summary. So we could see here that the abstract had 1,500 characters in length, but then the summary was only 332 characters in length. So that means that we're able to shorten the abstract by 1,176. This is an example of just how much we're able to condense things down using something like generative AI. And of course, this is an off-the-shelf implementation of Hugging Face text summarization. If you need to be able to make some changes to it and fine tuning, you could definitely do that, because in my opinion, I feel that maybe 300 or less characters is too condensed, especially for something that's 2,000 characters long. So one of the other pieces that I wanted to show would be the capabilities for doing some simple ETL. So similar to any relational database, this is where you could also do operations such as join operations. You could also do aggregation. So you can see here that we're doing some of values here. We're doing nested queries, and then if you just hit run, we could see that it's going to then generate the outputs here. And at a high level, you could see that this query ran in about 3.5 seconds and scanned 47 megabytes of data here. Last piece here would be, if we wanted to take a look at our abstract summary, the one that we did within our glue job. We could see here that, if you wanted to interact with the abstract, it's there. And then the summary is over here, and you could read a little bit more in detail in this. And now that it's available here, you could easily integrate that within any front-end applications. So I do want to conclude my demonstration here and be able to pass on the mic to my esteemed colleague, Ola.
Ola, I think you're on mute.
Okay. Well, thank you, Christian. So are you all seeing my screen?
Yes, we can see it.
All right. So in the interest of time, I'm only going to go over QuickSight. And before I do, my name is Ola. I'm a solutions architect at AWS. I've been in AWS for almost 2 years and excited to demo out QuickSight and how you can use it. So let's get into it. So I'm going to type in QuickSight in the search page. As we see, it takes us to the QuickSight landing page, and then the next thing we have to do is to import a data set. And I already have a data set that has been cleaned and transformed already, and we can also import data sets from multiple sources, also from external sources, as we can see from the options below, and we can also directly upload a CSV file. But I'm going to import the data sets from an Athena table that has been created previously, and I'm just going to name it as tests and leave the bar group as default, and then click on create. And then here, like we see the tables we have from the data catalog that Kristen talked about. So we can import these tables and visualize that using QuickSight. And so I have a cleaned data sets, and this data sets contains public health information. So I'm going to select that table, And here we have two ways of querying the data sets. We have Spice, which is an in-memory engine. With Spice, you're quickly able to analyze your, quickly able to query your data, or you can query your data directly, but this would take more time. So I'm going to use the import Spice option, then click on visualize, and then I'm going to create a new sheet. So here is how our data set looks like. Let me just preview that real quick. So when I click data sets and click on edit, as you can see, this is how the data set looks like. It's loading. It has the patient's ID, race, zip code, city, yeah, population. So there are multiple columns, and we'll be generating some visualization based on these columns. So I'm going to go back to the home page. So the first thing I would do is to create a donuts chart, and as you can see, we have multiple visual types. Like we have the maps, points on maps, pie charts. So any charts you're interested in, we have it right here. But I'll be using the donuts charts. And then the next thing I'll be doing is that I'm going to plot. I'm going to plot a donuts charts based on diabetes patients with who have type 2 diabetes. So I'm going to type in type 2 diabetes, and I'm going to drop that in the group sections under field well. And then we see the diagram here. As you can see, one is the amount of people with type 2 diabetes, and 0 is the people who don't have type 2 diabetes. And as you can see, we can see the percentages like right here, and we can also edit the title right here. So I'm going to put that as, I'm going to edit that real quick, save that, and we can also, for example, change the background colors to any background of our choice. So I'm going to change that right here. No, me. Sorry. Yeah, I'll just leave that as it is for now. Then the next thing we're going to do, we can also like plot KPI visuals, and that's what I'll be doing next. So we add a visual, as you can see on the top left, like we're able to add visuals, and under visual types we see KPI, and after doing that, I'm going to type in type 2 databases and put in the value, and as you can see, there are 20,000 people with type 2 databases, and we can also change the aggregates from sum to average or to max, median, or mean. So any aggregates of your choice. The next visual I'm going to be creating is a map visual. So this map visual will be using the zip code to identify the locations we need. So I'm going to put that in locations. Then we can also we can also specify the color we want, for example, based on the columns we're interested in. So I'm going to use the hypertension column and put that right there. And as you can see, we can see the counts of people with hypertension in each county. The next visual I'll be creating is a pivot table, and with a pivot table, we can specify the visuals under pivots table. Let me find that. Yeah. So here, then we need to specify the rows and the columns and the values that we're interested in. So for the rows, I'm going to use the states column. And as you can see, we see the counts of people or the counts of rows we have in North Dakota. Then for the columns, we specify the city, and as you can see, it breaks down the each city by its count. And let me expand on that so you can see it properly. And the values we're interested in will be the hepatitis tests. So I'm going to chop that into the values. And then I'm going to add in the year so that we can expand on each year and see how many cases we have by year. Let me change that to rows. So let me change that around actually. Yeah, so this is how it's meant to look. And as you can see, we have a pivot table that shows us the hepatitis tests by each year for each county. Are there any questions? And one more thing I should add is that you're able to publish and share the dashboard with your account users and external users. So I mean, just share it right here, publish dashboard, then give it a name, or then click on publish, and we'll be able to see the dashboards externally. Yeah, so if there are no questions, we're running out of time. I'm going to pass it on to Doneski or Ezo.
Thank you. Thank you, Ola. Thank you, Christian. Great job. Great job. Good presentations. I hope you guys were able to learn something today about these services that we discussed: AWS Glue, Amazon Athena, and Amazon QuickSight. And then you have a better understanding of how these services work in the analytics space within AWS. Does anyone have any questions? Does anyone want to say something before we dismiss today? So if you have any questions, just feel free to come off mute and tell us, or post it in the chat. Not sure if the UN wants to say something, Clarence.
Yeah, I just wanted to thank everyone for joining us today. And again, thank you guys from AWS for doing this for us. You know, the recordings that we put on the website have actually been getting a lot of views also for those. I think, you know, since we're global, not everyone, this time zone doesn't work out for everybody. But, you know, you guys are providing a great resource. And, you know, thank you again. And I just want to remind everyone else watching that tomorrow is the last the last official webinar for the UN Datathon, where we'll be announcing the theme that you'll definitely need to know for to compete in the event. So you know, join us live if you can, or watch the recording if you can. Thank you again.
Thank you. Appreciate it. See you next time.
Thank you so much. Bye.